All right, work equals force times distance. And force is a vector because we always give a direction and a magnitude for force. Distance is a scalar, it's just a magnitude. So work is a vector times a scalar, which is a vector. So suppose a constant force is applied to move an object along a vector PQ from P to Q. The work done by vector F is given by the formula magnitude F times the magnitude of vector PQ times the cosine of theta. So that has something to do with this formula. So this part of the formula is giving us the distance. Just the distance instead of the magnitude and direction of PQ. It's just giving us the magnitude of PQ. Okay, Taylor exerts a force of 10 pounds to pull her wagon a distance of 50 feet over level ground. If the handle of the wagon makes a 30-degree angle with the horizontal, how much work did Taylor do by pulling the wagon? Assume Taylor exerts the force of 10, I would assume that's a typo, 10 pounds. Sorry, I didn't find that and fix it. Pounds at a 30-degree angle for the duration of 50 feet. Okay, so using our formula, we want to start by finding the component form of vector F. So just in case you want a little picture to see what's happening, so the wagon's being pulled at a horizontal, but the handle of the wagon is pulling at an angle. I just lost my purple vector. Where did it go? That's not the one I wanted. Okay, that's not quite the one I was choosing, but oh well, it'll work. So this is 30 degrees in here. That's the direction of the force is being applied to move it this way. So this force is, this is going 50 feet. That really is just our magnitude right there, isn't it? And the angle for that is 0 degrees. So this whole formula here where it says do the magnitude of PQ times the cosine of theta, we don't really need to do that part because it would be the magnitude of PQ, which is 50, times the cosine of theta, which is 0. And so the cosine of 0 is 1, and 1 times 50 would still just be 50. So this is just finding our distance, and for this particular problem, the distance just happens to be 50 feet. And so you don't really need to go through that part of the formula unless you were pulling it across a distance that wasn't horizontal. So the fact that it's horizontal keeps that the same. So the hardest part of this problem is that we need to find the force vector. Oh, or we could switch it. Like we could do it both directions. Maybe that's why this problem goes with this, is to have us do the problem with, it gets confusing because we think, oh, force, that's F. And it's from this point to that point, so that's PQ. It's moving a distance of 50. So I suddenly wanted to start doing the problem with this being PQ and this being F. But what if we went the other way around? We could just follow the formula, right? I know I switch my goal in the middle and then we get lost. So let's go ahead and call F this 50 feet instead then. And I'm going to forget about all of this stuff. So we're going to call this F. So that means our component form for F is simply going to the right 50 and going up or down 0. So there's vector force F. So then this one is the other vector, and it's being pulled with a force of 10 pounds. Well, yeah, duh, that is the force. This one is actually, yeah, that's the distance. This is the force. This makes more sense. So this is a force of 10 pounds, but it's being pulled at an angle of 30 degrees. So following this formula, we are going to do the magnitude of F. So the magnitude of F would just be that 50, because we would do 50 squared plus 0 squared, square root is 50. So that's easy. And then work is going to be our magnitude of F times our magnitude of PQ, which they gave us is 10 pounds. So this is 50 times a 10-pound force at an angle of 30 degrees. So we go ahead and do 50 times 10 times the cosine of 30, which is square root of 3 over 2. And then we simplify this. So that's 500 divided by 2, which would be 250. So the exact answer of work done would be 250 square root 3, and the unit of that is what we call feet pounds. What's another unit for work that you learned about in physics, guys? Okay. Hi, am I here? Sorry. Um, sorry, just you finish talking about that. I've got to run to the door and grab something for Mr. Dixon. Hold on.